Hello, everyone, and thank you for tuning in to my talk at the EDA Summit 2022. I'm Nadine Alameh. I'm the CEO of the Open Geospatial Consortium, OGC, and I will tell you a bit more about that later. Today, I'll be sharing with you really my passion about location information and how do we go from location data, which we have so many of these days, to actionable information, which we need for decision making. And then where the EDA fits in this whole process. Before I get there, though, I really would like to thank Solus and particularly Richard Barton for inviting me to this event. I've worked with Richard and his team and his Solus team in the aviation domain for years. We were all contributing to the modernization of aeronautical flight, weather information management worldwide. And that was sort of my, exposure a little bit to what the Solus team does and to the principles, I think, of EDA. And if you're interested in how that works in the aviation domain, which is fascinating, it's definitely something you should look up and catch up on. So let's go back to EDA, though. I want to start with a little disclaimer, or maybe it's a big disclaimer. I am not an EDA expert. I am just a geospatial expert. And now, if you're wondering what geospatial is, I will ask you a question back. Have you recently started any question, right, with the word where? Where is my flight? Where is my Amazon package? Where is the war happening? Where are the fiber cables in my street? Where is the nearest hospital? Where's the vaccination site? Where can I fly my drone? I bet you have asked at least one of these questions recently. But, okay, another question for you. Have you recently done any of these things on this list? Have you used any type of map? Maybe, on your phone, a Google map, an Apple map for driving directions. Maybe you've ordered an Uber. Have you tracked any sensor recently? Traffic camera, satellite imagery. How about, have you ever used KML? Have you ever used GeoTIFF? Have you used data from anybody like NASA, like NOAA, like the FAA? I am willing to guess, to bet, right, that you've done many of these things, probably all very, very recently, and you've done them without even knowing. Essentially, you have been using geospatial technologies all along. And that's not a surprise. That's not a surprise to me, at least, because everything, at the end of the day, everything happens in space and time, right? And if you think about it, our challenge these days is how do we keep up with all the data that's around us? We have an amazing challenge because we have access to all this data in time and space, and we need to figure out a way to keep up with the deluge of data, of information, and to make sense at the end of the day of all that data. There's definitely, an explosion of data. So I'm going to show you here a couple of things. If you look at satellite imagery, so I spent part of my career at NASA working with Earth observation and satellite imagery. Part I mentioned to you earlier, doing aviation information exchange. It's all location data at the end of the day. But if I look at the satellite imagery market, and you check out here, and this is not even the whole market, right? Because commercial imagery is now actually in the news. But seriously check out the difference on this diagram on the left. Between 2015 and 2025, from 2.6 petabytes per year to 47.7, right, petabytes. This is just for NASA. The top one is on the European side. Again, this is the government. I'm not talking commercial. I'm not talking Maxar and Planet and the gazillion startups that are doing space, right? That's all the space stuff. But if I go back and I look at just the tabular data that we have these days, also think about it, that now we have archives, right, of cell phone locations, of smart car locations, traffic sensors, credit card transactions related to where the transaction has happened. This is just so much data. So for us, geospatial, I call us geospatial geeks. We think we live in an amazing times. So let me tell you why this is amazing. It's not just data and technology and innovation, but I start here, right? First of all, I'm gonna say it maybe a million times during this 30 minutes. There's more data out there, from sensors everywhere, Internet of Things, right? From small sats, from drones, from connected, autonomous vehicles, you name it. You couple that, right, with this second point over here, that this data that we're getting from these sources these days is actually more accurate than ever, more timely than ever, more real time than ever, because we have advances in GNSS, your GPS stuff. We have advances in 5G. We have indoor navigation data. We have underground navigation data, right? I mean, we're taking everything to the next level. The other advancement I'm excited about is the one here at the bottom of the screen, which is the cloud, because it's the only way we're able to handle all of this, to store, process, stream all this data and actually make it accessible. And then we get to the exciting stuff on the right-hand side, the visualization part, the advances in augmented reality, in virtual reality, the advances we're making to make data more easily visualized. We're now and I'll tell you a little bit about OGC, just if you give me just a couple more minutes, but we're actually working with the likes of Epic Games and Roblox, because the gaming environments, right, are now ready for all this data that I'm talking about. So we can incorporate all this real geospatial location data into the gaming environments and think about the powerful modeling and simulation environments we're creating, right? Marry that with all the talk about digital twins. And again, this is a whole other talk, but you quickly realize, I think this is like this bubble here. That's why we're talking a lot, or you hear a lot about artificial intelligence, right? Because there's all this data. I cannot process it one scene at a time and one sensor at a time and one archive at a time even. We need artificial intelligence and machine learning. And that's why we hear a lot about that, because it helps us keep up the big data analytics. So past all this amazing stuff, I will couple that with, the best part about geospatial, right? So when I get to the points at the end, you sort of know where I'm coming from. The best part about all of this, I think, is for us as a community of geospatial people and innovators, is the impact, right? That's why we're all doing this, right? I mean, the technology is fun and the innovation is amazing, but at the end of the day, we're all trying to help society, to help make the world a better place, leave the earth for for our kids in a better shape. So impact, geospatial is used for defense and intelligence. All these maps you're seeing on Ukraine and on Russia these days. In emergency management, when we see flooding and wildfires and landslides, that's all geospatial data, and we're using it to help save people's lives at the end of the day. Predict even flooding and hurricanes, because we now have enough data. That's also, again, where the AI, ML comes in. And then we help respond quickly by giving the right information to the right user at the right time. We don't give the user all the data in the world that I'm talking about here. So one last point here, that geospatial really touches every aspect of our lives. Look at COVID and how it showed the potential of geospatial data analysis for healthcare. You look at the mortgage crisis of 2008 in this case, and how these maps were used, in the official government assessment of what happened. But you can also imagine real-time mortgage trackers helping provide much more awareness as to what's happening and potentially prevent the next crisis. So at the end of the day, so it's interesting that we just had Earth Day 2022. So I think the biggest opportunity for data, for geospatial data, in my case, right, is to enable the sustainability transformation. So we enable society to value natural systems in the economy by measuring exactly what's happening around us, right? Things like, business ESG ratings, bank green bond verification, government regulation enforcement. These are all spatially, at the end of the day, geospatially location informed. So I hope I was able to convey to you that, to me, geospatial data is really at the center of all decision making about our planet. So I'm just gonna go and tell you that's why I love my job. So, and that's what we do, honestly, at the Open Geospatial Consortium. So we've been doing this for 27 years. We're a not-for-profit membership organization, the largest community of these geospatial geeks or experts, users, innovators, government, industry, academia. I have a sample on the slide of some of our members. We're over like 560 organizations as of today, but hopefully you recognize some on the sample, whether it's the NASA or the European Space Agency or the FAA or many other government agencies from around the world. All you recognize Google, Microsoft, Apple, Amazon Web Services, and there are tons of AI companies in the mix, because I told you that's the only way we can keep up. And then there's the Epic Games in the mix, because we're bringing the gaming into the modeling and simulation. So what we do here is we try to make, our mission at OGC is we try to make all this data that I'm trying to tell you is around us fair, findable, accessible, interoperable, and reusable. We do this by creating standards, by encouraging innovation, and by experimenting a lot. So what does that really mean, and where does that lead? So let me give you some examples, because sometimes, especially if we want to lead into the EDA linkage, you need concrete examples. So what does that really mean? So I'll give you just a few examples of the type of things that we do, and then you can follow with me. So here's an example here I have on the screen. APIs, right? So you got all this data. So we develop APIs for sharing, accessing, discovering location information. We are working with developers, right, on cloud native ways for exchanging, subsetting, discovering this geospatial information that I was just telling you about. We're working with, I go back to, a lot of data is coming from space these days. NASA, ESA, Planet Labs, Maxar, and many other platforms out there. And we're working on these platforms. How do we handle and process this big data? We have standards for retrieving information from sensors, because the other part of the puzzle, data from space, data from Internet of Things and sensors, just even more. Again, we're talking big data here. So we have, these standards for retrieving information, from sensors. We call them sensor things. And then it's not just how I get the information, it's actually how do you model that information so that other people can use it. So that's where the indoor mapping, for instance. So these are just examples. We have like 70 plus of these things. But the indoor mapping is of interest, at least to me, because it's actually was brought in by Apple. And it's because they're interested in mapping the inside, right, of every school, every mall, every warehouse, every government building, every airport. Fascinating. Equally fascinating, but and we're working on it, and it's just, I hesitate here because it blows my mind. It's like, we really don't have an underground model. Your fibers and your water and your electricity, it's a total mess underground. So we're trying to have a model for underground data. And then I get to how do you stream all this information, because we're now doing decision-making with phones, right? We're now doing decision-making everywhere, in the cars, right? I mean, again, think about it, on the drone. I'll tell you a little bit about edge computing in a minute. 3D data I mentioned earlier for like digital twins, right? And I mentioned the gaming companies because we're at a stage where we have this amazing data, right? Real data, not fake, it's not simulated, it's real. In these amazing environments that have been doing 3D and streaming and social interactions for a long time, and we're bridging these two. We're really bridging reality and virtual reality. We even have a metaverse working group right now in the Open Geospatial Consortium, because we need to build an open metaverse versus just a metaverse. But that's a whole different talk about the metaverse. It's exciting stuff. So we do all of this. We apply these cool ideas in different scenarios. So the scenarios, I've mentioned many of them already. Disasters, right? How do you track, predict, prevent, respond? Climate change comes up. I hope you hear about it all the time. No one has all the data you need. No one has all the tools. No one has all the expertise. It's a problem that is so global to start with, crosses boundaries of not just countries, it crosses boundaries of disciplines, of data types. And that's a problem that's very data heavy and requires, from our perspective, standards as the glue for the scientists and the decision making. And again, it's like actionable information instead of here's all the data that you need. This is going to bring me to EDA in just a minute. So many examples. I talked about smart cities, urban digital twins, really big these days, from just detecting, right, whether the trash cans are full so that they get picked up, right, in your city, in your park. That's such a simple and again fascinating example of smart cities. We'll get to that. Building intelligent infrastructures. I talked about health earlier. So it's supporting the decision-making. Marine is a huge issue. Again, if you're tracking the Ukraine-Russia, you'll see you'll see these use cases that are now bridging land, sea, air, right? And not too far is going to be also space. We need standards for all of these. We need data models, we need APIs, we need to understand what's happening, and we're not going to consume all the data at once. So what's bubbling up? I mean, I can't go on, but what bubbles up from all of this, I hope, is many things, but to me, two messages. Let's start with this first one. I take the disasters here as an example, so I'm going to zoom in on the disasters part. We really have fast-moving needs. A flood is a flood, right? Which happens in the developing world and in the developed world, right? Wildfires, California, Colorado, Canada had wildfires. It's crazy, flooding. Anyways, so we have these fast-moving needs. We have many stages in the disaster cycle, all fueled by data. We need to monitor. We need to predict. We need to detect. We need to alert. We need to respond, right? And so for the natural disasters, sadly, there are many statistics out there. I don't have a slide on that, but there are many statistics these days about how natural disasters are occurring more frequently, right? And they're more damaging overall, whether it's tornadoes or hurricanes or or flooding or whatever. So what can we do? What can we do given that we have all this data? I mentioned earlier the climate example, same question. I got numerical modeling data, social science data, Earth observation data, hydrology, infrastructure, atmospheric, weather. I can go on. You got to bring all of this together. So what's bubbling up here, and I hopefully you can see my mouse, is this now concept of analysis ready data. So there's the raw data, which is here it is, and good luck to you. And then there's the analysis ready data, so that we don't all have to start from scratch every time. And then there's this decision ready data, which is what application developers need to build decision-making applications on top of. Disaster risk reduction, or evacuation plans, or migration impact assessment, and so on. So because there's just so much data, right? You go from data to analysis ready data. So I think that's, one theme, right, that I want to convey to you that's bubbling up. The other theme that's bubbling up in this deluge of data is edge computing. And right now, if you think about it, the model is we bring the data. I mean, now we have the cloud at least, but we still, bring the data, whether it's from sensors or the satellites or the IoT devices or whatever, and you work with the data, you process it, you visualize it, blah, blah, blah. But now there's a huge buzz, it's more than a buzz, about edge computing. So what processing can we do on the edge, right? Whether it's in space. And so this slide, by the way, is from HP, Hewlett Packard, which is also one of OGC's members. And that's also another whole topic. But these guys are doing edge computing on the space station, right? Because you actually save a lot of data. Just getting data from space is expensive and it takes time. So why not do some processing on the satellites, in the space station, on your sensor, on your car, right? So that you eventually don't need the data as a decision maker. You just get this alert. You just get generated an event that you can then do something with, right? So let me show you. I think that's fascinating, and I swear this is a topic for a whole other talk. I'm showing you this also slide, which I downloaded a couple of days ago. So this is the latest landscape from a partner of ours called Tokyo Networks. I don't expect you to read the details, but you can check them out. but this shows you this growing landscape of edge computing. And if you zoom in a little bit at the top part, you'll see some applications for agriculture, smart cities, smart home, gaming, retail, supply chain. Just trying to read through these, and obviously so much more. So, which brings me back, I think, to this topic of EDA, right? So, EDA helps when you have a lot of data, and it's not just about the data. It's about what's happening, right? It's about the decisions that I need to make. It's about the actual information. And in our case, right, when we look at the location data, we definitely need new ways for dealing with this deluge of data. That's because now we say all data is geospatial, because everything happens in space and time. So how do you wrap your head around all of this to get, again, the actual information? So on top of analysis ready data, on top of doing some computing on the edge to reduce costs and latency and you name it, we shift from essentially, here's all your data, to event-driven exchanges. Instead of sending satellite imagery, I'll send you an alert when I see that a hurricane is forming somewhere. Again, that's why we're doing all this AI and machine learning stuff, right? Smart cities becomes about alerts. I mentioned when the trash cans need to be collected, that's the simple use case. But when energy consumption or air quality exceed some thresholds, and so we start to deal with these, key events that drive the workflow and that drive the decision making and drive who needs what data. So going from data to action, some takeaways is going to require all these ideas to work together, right? So you need, the event-driven architectures, you need the edge computing, you need this concept of analysis-ready and decision-ready information. We need all of this together if we want to address the complex problems of our time, like the disasters, like climate change, like the pandemics. So that's why I'm here at this summit. I'm here honestly to learn about how the EDA community can help with this concept of event-driven framework for location information that is obviously critical to our workflows and getting us, say it one last time, getting us from data, I'll say it differently, we're going to get from data to impact. So with that, I thank you again, for the opportunity to contribute, the opportunity to learn, and I'm always happy to connect if you have any questions. And I look forward to, connecting, hearing your questions, and learning more about how do we make an impact with all this power of technology, of collaboration, and really thinking big, because we're dealing with big data. So thank you again, and enjoy the rest of the event.